So for this video, I'm testing both of the endpoints of the interval, the 3 and the 7. So to do that, I'm going to go back to my original formula, and I'm actually going to plug in these x values. So instead of x minus 5 for the first one, I'm going to have 3 minus 5, which is negative 2. And instead of x minus 5 for the second one, I'm going to have 7 minus 5, which is 2. So this first one will look like this: sum from n equals 1 to infinity of negative 1 to the n plus 1, and then it was 3 minus 5, so negative 2 to the n, over n times 2 to the n. For this series, I have the sum from n equals 1 to infinity of negative 1 to the n plus 1, and this time it's 7 minus 5, so that's just 2 to the n over n times 2 to the n. So looking at these right now, this one's a little bit simpler. So you can see they both have a 2 to the n, so I can cancel those out. And what that leaves me with is an alternating series. Negative 1 to the n plus 1 will actually change from negative 1 to 1, negative 1 to 1. So I know this is alternating. So I'm going to take the limit as n approaches infinity of the non-alternating part, which will be a 1 over n. I know that that limit is 0, so this series converges. So I know that my series will converge when x equals 7, so that allows me to put an equal sign underneath that inequality. To check this, you need to know that negative 2 to the n is really negative 1 times 2 to the n, or negative 1 to the n times 2 to the n. So what's going to happen here is my 2 to the n's are going to cancel out, and I'm going to be able to combine this negative 1 to the n and this negative 1 to the n plus 1 by adding the exponents. So this will be the sum from n equals 1 to infinity of negative 1. When I add the exponents, that will be 2n plus 1 divided by n. And it might appear that this is alternating, but 2n plus 1 will always be an odd number, and negative 1 raised to an odd power is always just negative 1. So this is really equal to the series from n equals 1 to infinity of negative 1 over n. What I can do for this is, this looks just like a p-series, but it's a negative 1 instead of a 1. This negative 1 is just a constant that's multiplied in, so I can actually bring it out. So it's just like I have the opposite of 1 over n, and this is a p-series. P equals 1, which is the harmonic p-series, which we know diverges. So what that means is that this series does not converge at x equals 3, so I won't put an equal sign, and we have our interval of convergence.